It is 11:39 a.m. Eastern Time on October 4th, 2021. In an instant, the world's largest communication infrastructure simply ceases to exist. 3.5 billion people loses access to Facebook, Instagram, and WhatsApp. For casual users, it's an inconvenience, but in developing nations where WhatsApp serves as a primary infrastructure for commerce and emergency services, a sudden, absolute blackout is a crisis. The real panic, however, is happening inside Facebook's headquarters. The engineers scramble to diagnose the massive outage. They realize they can't log in. Their internal messaging tools are dead. The digital network has collapsed so completely that it has taken down the physical security systems. Engineers are quite literally locked out of their own server rooms. The giants hasn't just fallen, it has locked itself in a vault and deleted the key. To understand the sheer magnitude of this failure, you have to understand the scale of what Meta, then known as Facebook, has built. They didn't just rent space on the internet, they had essentially built their own parallel internet, a vast global footprint of custom data centers connected by miles of proprietary privately owned fiber optic cables. Operating a network of this size requires constant, invisible maintenance. Background updates, capacity checks, and routing adjustments happen thousands of times a day without a single user noticing it. But a network is only as good as the map used to navigate it. Think of the internet not as a single web, but as a massive collection of independent networks. If the internet is a global postal system, the Border Gateway Protocol, or BGP, is the GPS. It is the system that allows massive networks like Facebook to announce their presence to the rest of the world. BGP is how Facebook's server tells your local internet provider, here's the fastest road to reach us. Without BGP, the data centers might be powered on and perfectly healthy, but no one on earth knows how to find them. On the morning of October 4th, a routine command was sent to audit the capacity of this global BGP map. It was supposed to be a safe, standard procedure. The routine command issued to Facebook's backbone router was fundamentally destructive. It instructed the routers to disconnect the data centers from their main network. Facebook had an automated auditing tool specifically designed to catch and block the dangerous commands like this. But on this Monday, a software bug in the auditor caused it to fail. The destructive command slipped through. Instantly, the primary connections between Facebook's massive data facilities were severed. But the catastrophic cascade was just beginning because of a concept called a circular dependency. When you type facebook.com into your browser, you rely on the domain name service, or DNS, to translate those letters into a numerical IP address. DNS is the internet's phone book. Facebook hosted its own DNS servers inside its own network. When the primary backbone was accidentally severed, Facebook's DNS servers realized they were cut off from the data centers. Programmed to be helpful, the DNS servers automatically withdrew their BGP routing information. They essentially told the global internet, stop sending traffic to us, we are closed. The global fallout was immediate. Millions of small businesses lost their storefronts. In countries like India and Brazil, government hotlines, telemedicine providers, and emergency responders who relied entirely on WhatsApp were suddenly cut off from public. And inside Facebook, the situation was paralyzing. Because their internet communication network shared the same infrastructure as the public sites, the engineers tasked with fixing the internet's biggest platform were reduced to coordinating on private Discord servers and personal iPhones. Remote access was completely dead. The engineers could see the problem, but they had no digital tools to reach into the network and reverse the command. The recovery required an agonizing manual physical intervention. Specialized teams had to be dispatched in cars in physical data centers in Santa Clara, California. Because the corporate network was down, their security badges didn't work to open the doors to the server cages. Once inside, they couldn't just plug in a laptop and fix everything at once. They had to hunt down specific master routers and physically connect to them using hardware console cables. They had to manually override the systems, bypassing the broken network to speak directly to the hardware. Even after the routers were restored, they couldn't simply flip the switch back on. If 3.5 billion users tried to reconnect and refresh their feeds at the exact same microsecond, the resulting surge in traffic would act like a massive cyber attack, crashing the servers all over again. Engineers had to painstakingly throttle the traffic, bringing the world back online fraction by fraction. Duration of the blackout 5 hours and 45 minutes. Global users impacted 3.5 billion. Estimated financial cost to the company up to $100 million dollars in lost ad revenue. Market impact a nearly 5% drop in stock prices, erasing billions in the market value in a single afternoon. The 2021 Facebook outage serves as a terrifying lesson to the fragility of extreme optimism. The tech industry has spent decades building highly integrated, highly automated systems designed to be faster, smarter, and self healing. But when you build an infrastructure where everything depends on everything else, where the system you use to fix the network relies on the network itself being online, you create a perfect condition for a blackout hole. The outage was not caused by malicious hackers or state sponsored cyber warfare. It was caused by a routine check, a single bug, and an architecture that forgot to leave a spare key under the welcome mat.